seconds late. Volume. Volume. All right. Normally, with volume, this is going to be the shortcut of it. You guys can watch it. It's on YouTube, etc., etc., etc. Shortcut of it is the easiest way, since we know how to do areas, the easiest way to make a volume is to accumulate slices, and that kind of makes sense. Like, put all the slices together, you have a whole loaf of bread, right? Put all the slices in a tomato together, you have a tomato, etc., etc., etc. I'm going to stop. But what's true of all these slices? We could say they represent the second dimension, but are they actually two-dimensional? Because to be two-dimensional, what has to be true? It has to have no depth. So then here comes the study of calculus. It says, hey, can we accumulate an infinitesimally thin, well, here, can we accumulate across an interval infinitely many infinitesimally thin parts to figure out the entire measurement? Yes. So for area, we accumulated infinitesimally thin rectangles, aka in a sense we were accumulating lines to make area. That doesn't make sense, but with calculus it's possible because of the limit thing. With volume, we can accumulate infinitesimally thin slices. Wait, they have no depth, but we can accumulate them with integration, and then we can get the volume of the whole. So there's lots of different craziness, this, that, and the other. I will show you probably the best example to illustrate. Here we go. Is that a geometrical? Geometric? Geometric solid. Cylinder. Sphere. No. The solid's not. But is the cross-sectional slice? Yes. Cross-sectional slices. Here we go. We did a forever card on Friday. Basically, the volume is equal to the integration, the accumulation from one bound to another bound of areas times depths. Easiest one to show you this is an area, no. Volume of a cylinder. Real quick. Volume of a cylinder is? Pi r squared times, where's the pi r squared come from? Okay, so in essence, pi r squared h is taking the base and it's accumulating it all through the height, right? Basically, it's integration. Coming back. So what I can do is I can accumulate areas times depths, but the depths are becoming infinitesimally thin. That's what the integral does, and it accumulates them all. Anyway, long story short, one more thing to talk about is with areas, could you kind of choose whether it's x or y? Yeah. Whether in terms of x or in terms of y? With volumes, can you? No, it is defined for you. Whatever you're taking, however you're slicing, determines whether in terms, if you're slicing perpendicular to the x, let me show you pictures. Where's the x? Here he is. If you're slicing perpendicular to the x, think of a hollow knife, and as it, like blade, and you're cutting, right? As you pull up the slice, the depth would be change in x, and that's what needs to get infinitesimally thin, so it's dx. This one is the exact same. Do I have another picture close? No. Yes, the example that we were on.
Oh, that's right.
Slice is perpendicular to the y-axis. Think of your hollow knife again. As you slice, the depth would be change in y, so it's dy. Did I label that y? Here he is. So I have to do my integral, well, okay, there can be a debate on this one, because technically it's a circle, and so you think if you go this way or that way, it's the same half sphere. But anyway, usually, if you cut it the way that the picture is drawn and the way that I have my formula set up, I have to go dy. Okay, what's the area formula for a semicircle? 1/2 pi r squared, right? But hold on. If I was to go from side to side, let's go back for just a second. Kiddos, how did I figure out this whole mumbo jumbo in the middle in my area formula? What was the area of a square? Side squared. And what measures the length of the side? The area between, right? So I did one curve minus another curve, measures the side, so I plug that into my area formula. Ba-doom, ba-doom, I have an integral to solve. I'm not showing you integration right now because we've been there, we've done that. You've been there, you've done that. You can continue to do so, right? Question. I did this really fast at the end of class, I believe, on Friday. How did I get square root of 4 minus y squared plugged in for r?
Because of the radius.
Wait. First of all, why this and not that? This is in terms of x's and y's. That's horrible on so many different levels, right? I need it in terms of one variable. Why did I do it in terms of y? Because, well, I did dy. Oh, no, you're good. Sorry. Judge, I apologize. That was a false accusation. Coming back. I need to go from one side to another. I didn't clearly show this on Friday. This half would be x equals 4 minus y squared. What would the other half be?
No. Yes.
It'd be the negative square root of, right? And you're like, but wait, those aren't functions. Well, they kind of are with respect to y, just not with respect to x. I just blew some of your minds. Don't think about it too hard. Okay, so I have the right-hand side, positive root, the left-hand side, negative root. So you could think positive root minus negative root, but the problem is that would be the diameter. So why did I only go halfway? Because I was looking for radius. So I went from positive square root of 4 minus y squared to, what line is this? Y-axis, which is x equals 0. So it's like I've subtracted this one minus 0. I got that. I went ahead, plugged in, and now it's time to integrate. How'd you guys integrate, just to make sure that we could do it? Easy, right? And then pull out? Is that what you guys said? Pull out the pi? And then I have 4 minus y squared power rule. I know, I told you to do it, so now I feel bad not doing it. So then I end up with 4y minus y cubed over 3 from negative 2 to 2. Right? So then I plug in and I have 1/2 pi times 8 minus 8/3 minus negative 8 plus 8/3, which distributing my negative, and I get 8 plus 8 is 16, and negative negative would be, this is really similar to like a test question, isn't it? Weird. Negative, not this last test, the one before, I think. 16 minus 16/3 would end up being 48 minus 16/3, is that right?
Isn't it negative 8/3 and positive 8/3?
Who's negative?
It was a negative, but there was a negative 2 cubed, which made it a positive, but then it was minus a positive, which makes it a negative. Don't worry, I'm careful with my negatives. Otherwise you can kill things. Then I have 48/3 minus 16/3, which would end up being what, 32/3? And 32/3 over 2, 16/3. Wait, really? Is that math right?
Wait, I don't know. I got the same answer, but
So I can do times 3 over 3. So I have 3 16s minus 1 16. Yes, please.
Oh, I think.
Does that make sense? 48 minus 16. We're just checking my math. I think my math's good, right? 32, 32 over 2 is 16, 16, 32. Josh.
How come when you have the 1/2 pi times 4y minus y to the third over 3, it's minus, but then you go to f of b minus f of a part, it's positive.
No. You guys are killing me. Here. It's minus, and then a negative 2 is a negative, and then I said, hey, it's a plus, and then I distributed in my negative.
Okay.
Yeah, I'm careful with my negatives. Sorry, questions. There's a lot of, but I think it's okay. All right, let's keep going. What if I was to ask for not squares? We already did that one. Equilateral triangles. That sounds interesting. And then we'll stop. Guys, good thing is, the AP would never be like, haha, equilateral triangles. Do you have that one memorized? They'd be like, in parentheses, the area is, okay? It's not going to be a big stressful thing. But if it was popping up in equilateral triangles, this time let's say perpendicular to the x-axis, just for sake of argument. If we're doing with respect to the x-axis, I'm thinking of area in terms of x times dx. Guys, what would my bounds be for this one again? Yeah, because it's my radii, so negative 2 to 2, good. What's my area formula for equilateral triangles? Well, long story short, you got it. When you cut it, that's the side, that's 1/2 the side, because it's going to be bisecting it. You're going to have a 60, 30 degree triangle. Across from the 60 is root 3 over 2 times s. Then you plug in and you get area is equal to 1/2 whole base is s times height root 3 over 2 times s. Therefore, root 3 Once again, they might be nice. They would be nice. They wouldn't force you to remember that from who knows when. You probably never memorized it. Anyway, there it is. So if we're going to use that, what do we need to measure? It's just an area formula. Think area of a square, side squared, area of a rectangle, base times height, area of an equilateral triangle. If you Googled it, root 3 over 4 s squared. What's s? Well, I'm slicing this way, right? And when I slice this way, and I pop up in a semicircle, technically it has a little bit of depth. Anyway, long story short, ooh, that's ugly. Sorry, I apologize. That's why it's dx, because it has a little bit of depth. Oh, it's a triangle. Thank you. I was still back on the last example. Triangle. That's not that. Triangle would be...
That's a rethink of my life.
Right? I don't know. It's close. So we have our triangular slice, and of course, if you guys can kind of tell, it would kind of go like this, sort of, because you would have like little baby triangles here. Right? And then you would have like another like a medium triangle here. Whatever. Calm down, calm down. Alright guys. So what would I plug in for side? Because I know that I have negative 2 to 2. I know that I have root 3 over 4, right? And I know that I need side squared dx. So what's my side? What have we not done yet? Wouldn't that be? And then wouldn't that be? Right? So then couldn't I just say the top minus the bottom? Oh, so if I had the top minus the bottom, I'd have square root of 4 minus x squared. Some of you I know would do this quicker, but minus and negative, square root of 4 minus x squared. Hey, minus and negative, what's that?
Plus.
Whew, all right, we got that. Got it? So then I end up with
2.
double. Careful, my one's prone to math mistakes. Don't pull the 2 out yet, because what's going on the outside? So then, so many things to keep track of. Double the 2, it would be 4. The 4 comes out, cancels out, end up with root 3 of negative 2 to 2. I'm not going to keep solving because you guys would just get bored if you're not already with how much I'm integrating. Solve. But does plugging in make sense? I need the area formula. I need my side. Equilateral, all the sides are the same. If I find one, I find them all. So how do I find the side? I need that length, but that length is the top curve, theoretically area under, minus the other curve, which is a negative, so I need minus to add it. Or some of you might have jumped straight here to 2 times because of the symmetry. Questions? Can we zoom ahead to, okay, we're going to end here. Doing good. Wait a minute, decimals. Haha, you can use what?
Calculator.
For the whole thing, for graphing it, for intersecting it, for integrating it. It's a good day. Question. What are they asking though?
Which of the following is the best?
Come back, read the whole question. My ones who just skip to the end.
Oh, okay.
Ruh-roh.
Square.
Cross sections. That tells me what kind of problem this is, right?
Yeah.
Perpendicular to the x-axis tells me orientation. Squares tells me what area formula to use. Can I give you 2 minutes and see if you guys got it? You can use whatever you want with your graphing calculator, or I guess you could do it, buddy. If you want to use your calculator, that's cool. You can graph it. It'd be totally allowed. You want to use your calculator to integrate. Wait. We're solving the example. Oh, my ones. Okay. We're not done yet. Hold on. We're still working. Sorry, I'm just going to jump to the interval that you should have. Sounds like a great idea. Ooh. Apologies, that was gross. I'm done. Put the shovel down. Okay, so. Hold on, double checking. I see lots of hands and confused looks.
Is it ln of x, y equals 0? No. There's no 1.
Okay, 1. Oh, you mean here?
Oh, I'm there.
Here? That's
Yeah,
true.
that would be 1, 0. Because Nella is like starting,
Ah,
right? So you're
got it, tracking. What would have happened if you guys plugged it in? You caught it too soon.
It would have been error 2.
It would have been, well, try it.
1 over 0.
Okay. It would have been an error because it's an improper integral because you're getting infinitesimally close to 0, so that would have had issues. You're right, it intersects at 1 ln of, because remember ln keeps going down. But anyway, improper integrals are Calc 2, you're right, I shouldn't have. My other point's good as well, but this one is the one they were talking about. Do we got it? Yeah, don't forget the squared or else you're going to have some issues. So then when we go ahead and plug in, we have from 1 to e. And now I have my paranoid ones who are maybe like me, who have been really careful. Oh, I'm in sequence mode. Stink, is that going to make a difference? I have no idea. Hold on. Sorry, pre-cal. I know, pre-cal. Shh, we should... I got out, didn't it? Lame. Come on. Is anybody else confused? I don't know what's going on. Guys, what's the answer? I give up. My calculator is like spazzing. A? Do we all agree?
Yeah.
Did you square it? Are you sure?
Yeah.
Okay.
What'd you get last class?
Sorry, if my calculator... I don't know what's going on. Okay, maybe I can make it to work. There we go. Guys, I give up. You guys already found it. It's A. We're going to go ahead and start transitioning to the gym, but wait, hold on. What if I was to ask you, we're not actually going to solve it, what's different about this one? You get back up, what's different?
The y-axis it says revolve.
It says what?
Revolve.
We're going to start revolving things? Paraboloids, hyperboloids, but this time it's just curves. We don't really care what shape it is because we can do all of them. All right, cool kids, that's tomorrow. Here's what I need. Ready? You're going to leave your stuff here for right now because you can come back and get it. I'm not going to lock the room, and I need hands because technically the next 7 minutes are still mine, right?
Yes, ma'am.
I have 1, a 2, a 3 drawers full of pies and circular desserts. Don't carry more than you can handle. If I see pies on the ground, I will be very unhappy. Just a heads up. I also have 2 pies in my fridge. I need people to take and my pie, please. I have napkins and plates and forks. In the gym when we go there, pizzas will be on one side, pies you can kind of just scatter around on the other side. Knives need to go next to most of the pies just so hopefully we don't have disasters like last year of 1 spoon being used for like apple and chocolate and plates. Put up by the front of the table, now you guys got it, right?
Yeah.
Okay, stand up, don't trample, slowly, pick up something, go to the gym, bye. 2 people, 3 pies, right here.
Emily Sabino, your cake is fine.
False.
Matthew. You know what?
Are there any names? I don't really care, I don't need the names still, I already wrote them down.
Oh, you can take my name off of it now.
Alright.
Kenny, don't worry, they're not the pies. Oh, I'm small.
Oh, pie.
How you doing?